Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to create a gradient boosting classifier model. Alright, so prior to this video I've already split my data into training and test data set, and I've already cleaned my data. So if you want to learn how to split your data, go ahead and watch the video. I'm gonna leave it in the description below. But since I've already split my data and I've already cleaned my data, let's go ahead and begin. So this is my training data and it looks similar to my test data, of course. And basically these are the features that I'm going to be using to predict wine quality. So this data frame or this data set is predicting wine quality, and we can get a preview of the training data, the target values, and this is kind of just like a preview of like the first 5 values for wine quality. So this data set is about predicting wine quality. So first of all, let's go ahead and import our gradient boosting classifier from Sklearn.ensemble. Import gradient boosting classifier. In a different video, I talk about how to use gradient boosting regressor, but this video is focused on gradient boosting classifier. So next thing is to instantiate the model, and we are just going to call it why not? It's equal to gradient boosting classifier. And we are just going to use all the default parameters, and we are going to set the random state equal to 42. And basically random state is just for consistency, so that next time I run this code I'll kind of get the same result because everything is consistent. So after instantiating the model, let's go ahead and fit the model through our training data set. But before we do that, let me show you something real quick. So this is the gradient boosting classifier documentation from Sklearn, and if you scroll down here you can see the different parameters you can modify if you want, and then you can see the attributes down here, and these attributes are things you have access to after you have trained and after you fitted your model through training data set. Okay, and if you go down a little bit you see the method. So this is a different methods you have access to in the gradient boosting function, and I'm going to be using the fit method, the predict method, and the scoring method. So if you see me using something like .fit, .predict, and .score, this is where it's coming from. So with that being said, let's go ahead and fit our data frame, fit our data. So we just do gb model.fit, and we want to fit our training data, and then we want to fit our training target. Alright, so our gradient boosting model is done fitting our training data. Now let's use our gradient boosting model to get a prediction. So we are going to store this in a variable. Let's call it ypred_gb is equal to gb model.predict, and we are going to do the prediction using our testing data. Alright, so we have done our prediction. So we fit the model with our training data. We've gotten a prediction, but how do you actually know if this model is good or not, right? You have to be able to evaluate the performance of this model. If you're working with a regression problem, you use a regression matrix to evaluate the model. If you're working with a classification problem, you use classification matrix to evaluate the model. And since this is a classification problem, one of the most popular classification metrics to use is accuracy score. So we are going to get the accuracy score from this model and we are going to compare it to the accuracy score from other models to kind of evaluate how good this model is. So I'm going to show you two ways to get accuracy score. One of the first ways to get accuracy score is using the built-in scoring method of the model. So if you do GB model dot score, and then in parentheses you put in your S test, and then you put in your Y test. And let me go ahead and add comments here. As you can see right here, our accuracy score is about 59%. That's not bad at all. This is just using the default parameters. As you might have noticed here, I didn't do anything special. I just used the default parameters that comes with the model. Now this is one way to get the accuracy score. Another way to get the accuracy score is using scikit-learn accuracy metric. So if we go ahead and do from sklearn dot metric, import accuracy score, and then we just do accuracy score parentheses y test, and then y pred GB. All right, if we go ahead and run this, you see we get the exact same score. So if you're going to use the built-in scoring method, make sure you put in your S test and then your Y test. If you're going to use the accuracy score from scikit-learn metric library, then you put in your Y test and your predicted values. So when you use this method, it's gonna get the predicted values for you and then give you the score. But if you're going to use this method to get the accuracy score, make sure you get your predictions first and you put in the predicted values right here. But it doesn't matter which method you use, you will get the exact same result. So now that you have the accuracy score for your gradient boosting classifier model, how do you actually know if this accuracy score is good or if it's an improvement? Well, the best way to know the goodness of this model is kind of like to compare the accuracy score to like your baseline accuracy score. In a different video, I show you how to get the baseline accuracy score, but right now I'm just gonna go ahead and get that information, and then I'm gonna show you the comparison between this one and the accuracy score and from the baseline and from the other models that I've built. So I went ahead and got the accuracy score for different models that I've already built, and let's get and run this. And as you can see right here, so my baseline accuracy score was 45%, and then I ran this dataset through a decision tree classifier. I got an accuracy score of 59%. A random forest classifier gave me an accuracy score of 66%, and a ridge classifier model gave me an accuracy score of 52%. And compared to the gradient boosting model accuracy score of 59%. So the gradient boosting model kind of gave me the same accuracy score as my decision tree classifier, which is better than the baseline accuracy score and also better than the ridge classifier accuracy score. And so far, the random forest classifier has produced the best accuracy score. So you can see that our gradient boosting model is better than the baseline, but it's not like the best model for this. This is just using the default parameter, not hyperparameter tuning anything at all. So you have fit your model, you've gotten your prediction, you've gotten your accuracy scores, but how do you actually explain your model, right? If somebody was like, hey, which features in your data frame are most important? Which features in your model are responsible for this accuracy score that you're getting? How do you explain it? Well, one technique you can use to explain it is by looking at the future importances for this gradient boosting score. So if I do GB model dot future importances, you get these numbers. So what does these numbers actually mean? And how are you going to use these numbers to explain your model? And what other techniques can you use to explain your model? So in the next video, I am going to show you how to explain your gradient boosting model. Make sure you subscribe to the channel so you get notification for that video. And to get access to this notebook that I use in today's video, just go to machinelearningeducation.com. This is a platform where I put my notebooks. And if you go here, free data science resources, you'll be able to get to this page. And the link to this directly is machinelearningeducation.com/free. And from here, you'll be able to get access to this notebook I use in today's video and my other notebooks. I create a lot of YouTube videos and a lot of blog posts, and I just find it easier and more straightforward to take all my notebooks, all my data science resources, all my videos, all my blogs, and put it under one platform. And that's machinelearningeducation.com/free. You can also visit me online at evidencen.com. This is my primary website where I have my data science blog posts. And if you scroll down here, you can see my data science blog. As time goes by, I'm going to add more and more stuff to my data science blogs. And while you are here, you can also click free data science resources to be able to get to this page. That's it for this video. If you like it, please give it a thumbs up and subscribe to the channel. If you made it this far in this video but you didn't like it, please give a double thumbs down and still subscribe to the channk. Thank you for watching, and I'll talk to you on the next one. Bye.